The Friction Mission: Understanding Static and Frictional Force.
Hi everyone! Welcome back to our mini science talk. Today, we're going to talk about something we experience every single day: friction.
Friction? You mean that thing that makes it hard to slide my notebook across the table? Exactly. Friction is the force that resists motion between two surfaces that are in contact.
In short, it's the reason why things don't just keep sliding forever.
And today, we'll focus on one special kind of friction: static friction, also known as the friction that keeps things from moving.
What is static friction?
Static friction acts on objects that are not moving. It prevents an object from sliding even when a force is applied, until that force becomes strong enough to make it move. So it's like me. I won't move unless someone pushes me first.
Exactly. You're like an object with maximum static friction.
Let's say I'm trying to push this box on the table. See, it doesn't move yet because static friction is still stronger than my push.
That means the applied force is less than the maximum static friction.
But once I push harder, boom, it moves.
That's when the applied force overcomes the static friction.
Wait, so when it starts moving, is that still static friction? Good question. Nope. Once it starts moving, it becomes kinetic friction.
Static friction keeps the object still. Kinetic friction acts while the object is already sliding or moving.
And usually, static friction is greater than kinetic friction. That's why it's harder to start moving an object than to keep it moving.
So it's like when you're exercising. It's hard to start, but once you get going, it gets easier. Here's the formula. F sub s is less than or equal to mu sub s times n, where F sub s means the static friction force, mu sub s is the coefficient of static friction, and n is the normal force, the support force coming from the surface.
Less than or equal to, because static friction adjusts itself. It increases as you push harder until it reaches its maximum limit.
And that's when motion begins.
So what are the factors that affect it? Good question. Static friction depends on two main things. One is the roughness of the surfaces in contact. Two is the normal force, which usually depends on the object's weight.
So, the heavier the object, the greater static friction.
Okay, let's apply this in real life.
Example 1. When you're trying to push a heavy cabinet, it doesn't move at first. That's static friction at work.
Example number 2. When you walk, your shoes grip the floor because of static friction. It prevents you from slipping. Example 3. Car tires. Static friction between the tires and the road lets the car move forward without sliding.
Without static friction, walking or driving would be like trying to move on ice. You just slip.
Here's a simple demo you can try at home. Place a book on a table, slowly push it until it just starts to move. That's the point where your push equals the maximum static friction.
If you add another book on top, it'll take more force to start moving because the normal force increased. So the heavier it is, the stronger the grip.
So to sum it up, static friction is the force that keeps objects in place until a strong enough force makes them move.
It depends on how rough the surfaces are and how heavy the object is.
Once the object starts moving, static friction ends and kinetic friction takes over. That's why no motion happens without overcoming resistance.
Static friction may seem simple, but plays a big role in our daily lives. It keeps our feet steady, our cars safe, and our objects in place. Without it, movement would be uncontrollable and unbalanced. So, the next time something doesn't move right away, remember, static friction is at work. And that's just one of the many forces that shape our everyday world. Science isn't just in the lab, it's in every step, every move, and every moment of balance. Sometimes, the things that we don't see, like static friction, are the ones that keeps everything together. Maybe science isn't just about motion, but about what keeps us together too.
That concludes our presentation on static friction. Thank you for watching. And remember, there's always more to discover in the world of physics.